Hello everyone. Today I am going to discuss about the measurement of seasonal variations which are present in time series data. Myself Dr. Ranjana Gogoi, Associate Professor in Statistics working at Gorgaon College, and today's lecture is based on the syllabus of BSc non-CBCS 6th semester Statistics Major Paper Applied Statistics, which is taught in the colleges under Dibrugarh University for undergraduate students. Now, measurements of seasonal variation. The objectives of studying seasonal variations in a time series are required for the following reasons. They are to isolate the seasonal variation, that is, to determine the effect of seasonal swings on the value of the given phenomenon, and to eliminate them, that is, to determine the value of the phenomenon if there were no seasonal ups and downs in the series. This is called the deseasonalizing the given data and is necessary for studying cyclical variations. The determination of seasonal effects is of top importance in planning business efficiency or a production program. For the study of seasonal variation, the data must be given for parts of year, namely monthly, quarterly, weekly, daily, or hourly. One of the method of measuring seasonal variation is the method of simple averages. This is the simplest method of measuring seasonal variation in a time series, which involves the following steps. First, you arrange the data by years and months or quarters if quarterly data are given. Then compute the average xi bar I equal to 1, 2, 3 up to 12 for the ith month for all the years. The ith month represents January, February, etc. Then compute the average x bar of the monthly averages, that is, x bar is equal to 1 by 12 summation of I from 1 to 12 xi. Then seasonal indices for different months are obtained by expressing monthly averages as percentage of the x bar. Thus, seasonal indices for the ith month will be equal to xi bar divided by x bar into 100, and here I takes the values 1 to 3 up to 12. That is, for different month, different seasonal indices we have. Instead of monthly averages, monthly totals for all the years can also be used. The result remains same. Total of seasonal indices is 12 into 100, that is 1200 for monthly data, and for quarterly data 4 into 100 equal to 400. Now merits and demerits are, this method is based on the assumption that the data do not contain any trend and cyclical components and consist in eliminating irregular components by averaging the monthly or quarterly values over different years. Since most of the economic time series have trends, these assumptions are not in general true, and as such, this method is not of much practical utility. Our next method is ratio to trend method. This method is an improvement over the simple averages and is based on the assumption that seasonal variation for any given month is constant factor of the trend. The steps followed in measuring seasonal variation by this ratio to trend method are: first, you compute the trend values by the principle of least squares method by fitting an appropriate mathematical curve. Then express the original data as the percentage of the trend values. Then assuming the multiplicative model, these percentages will contain seasonal, cyclical, and irregular components. The cyclic and irregular components are then wiped out by averaging the percentages for different months or quarters. For month, if the data are monthly, and for different quarters, if the data are given in quarterly basis, thus leaving us with indices of seasonal variation. Either arithmetic mean or median can be used for averaging, but median is preferred to arithmetic mean since the latter gives undue weightage to extreme values which are not primarily due to seasonal swings. If few abnormal values are present in the data, then modified mean by calculating arithmetic mean after dropping the abnormal values may be used with advantage. Finally, the indices obtained in the above step are adjusted to a total of 1200 for monthly data or for 400 for quarterly data by multiplying them throughout by constant k, which is given by, for monthly data it is equal to k is equal to 1200 by total of the indices, and for quarterly data k is equal to 400 by total of the average. The merits and demerits of ratio to trend methods are as follows. Ratio to trend method attempts at smoothing out the cyclical or irregular components by the process of averaging. The purpose will be achieved only if the cyclical variation are known to be absent. On the other hand, if the series exhibits cyclical swings, the trend values obtained by the least squares method can never follow the actual data as closely as 12-month moving average. As such, the seasonal indices obtained by ratio to trend method are liable to more bias than obtained by ratio to moving average method. So dear student, I conclude today's lecture here. Thank you.